Hi, this video will cover multiplication strategies for 2-digit times 1-digit numbers. Today, students are expected to understand the why behind how we multiply 2 digits times 1 digit. Many of us learned a typical algorithm where you multiply the ones times the bottom number, regroup as necessary, then you multiply the bottom number times the number in the tens place, and add anything that you regrouped. Students will learn that algorithm later on. However, they're expected to have some concrete models that help them to understand why that algorithm, or the way that we learned how to multiply, really works. It helps to avoid confusion on the part of a lot of students, and it gives them a strong conceptual background mathematically for understanding what's really going on in that algorithm that typically we use for multiplying 2 digits times 1 digit. Students in 3rd grade have learned 4 different strategies for multiplying 2 digits times 1 digit. They're expected to understand all 4 models, and again, for many students, this gives them the opportunity to see multiplication in different ways. For example, while some students might understand the algorithm that many of us learned for multiplication, sometimes students don't, and the bar model in this case might help them, or partial product or base 10. Basically, we're giving students options here, and we're giving them very concrete, hands-on tools so that they can quickly get to answers. Again, this is not something that they may use forever. They'll go to the algorithm eventually, but it's building a conceptual background for them. And so this video looks at how each of these 4 models are used. It's a good idea in the problem solving and in homework to have your child incorporate one of these 4 models so that they're really using what we're doing in class. So the first model we'll look at is the bar model. And this strategy helps students to remember that multiplication is really repeated addition of equal groups, and it uses concrete blocks or bars to help them to see how repeated addition is like multiplication. So you can see that we have here a 2-digit times 1-digit problem, 24 times 3. And what I'm going to do is I'm going to take 3 different bars, 1, 2, 3, and if I were to add 24 plus 24 plus 24, the new quantity or answer would be 72. So it reminds students that multiplication is really repeated addition, and some students, until they get a firm understanding of multiplication, will go ahead and add numbers multiple times. This is okay as they're developing a sense of what multiplication means. Here's a picture of those bars that students would use in class, and I can use any number with this. If I were to say that, for example, this is this stands for 3, for example, okay, I would explain that these bars represented the number 3, and so in this case I have 3 times 3, and here this shows 3 plus 3 plus 3 is equivalent to the answer 9. So 3 times 3 equals 9 using the bar model. Again, this highlights the concept that multiplication is repeated addition. Also remember that I can use any number. So if this was, 3 times 6, the green bars would just be represented by 6. So it's very concrete. The next strategy is called the base 10 model. And this strategy really focuses on place value and really will connect well with kids later when they do learn that algorithm. It helps them to understand why you do the ones place separated from the tens place when multiplying by that number in the bottom. Okay. Students will use what's called base 10 blocks to show multiplication of the numbers that they have. Notice that in this corner here, the base 10 model uses separated blocks. That's important when we look at the next strategy. So I'm focusing on that same problem, 24 times 3, and you can see here that these rods represent tens. So I have 10, 20, 21, 22, 23, 24, okay? And so the students actually build this in a line, just like it's shown here. And this would represent 24 3 times. Now the nice thing is that, especially for students who need something more concrete, all I have to do then is look right here and I can quickly see this is 10, 20, 30, 40, 50, 60, or 30 plus 30. And then I can see here this is 4 times 3, which is 12. So 60 plus 12 equals my answer 72. That again is the base 10 model. We call it that because we're using place value blocks based on our numeric base 10 system. The next strategy is known as the area model, and interestingly enough, this is a lot like the base 10 model, but the difference here is rather than having separated blocks, in the area model, the blocks, the base 10 blocks, become attached. So this is very close to the base 10 model. Remember, up here I have separated base 10 blocks, okay? And down below, this is what we would call the area model. Again, each of these strategies are used to highlight a certain mathematical concept. And in this case, we're showing kids that multiplication is the basis for area later. So when they learn the difference between area and perimeter, they have this framework to understand that area are these tiles connected and multiplied in an array type form. So it's still the same concept. You have 30 here, plus 30 here, plus the 12 with the ones place. And again, it goes tens on the left and then ones on the right. And then if I add that together, that 60 plus 12 equals 72. Just a different way to look at multiplication. And again, it's building their understanding later for how area will work. One thing to keep in mind is that kids are learning that anytime they see a grid, it's kind of a map for area model. So in those PODs, wherever you see kind of grid paper with small squares, you'll notice that those are just maps for tens and ones and hundreds there. They learn to highlight in those rows of tens and ones for the area model whenever they see that grid type paper to use. And the last strategy for 2-digit times 1-digit is called partial product. This is really a neat way to show kids who are pretty early in multiplication concepts how to multiply 2 digits times 1 digit. I'll show you how this works. Let's say that I take that same problem, 24 times 3. I'm going to take this number here and put it out front, the 3, and then I'm going to take the 20 and break it apart into tens and ones. So I'm focusing on place value. I'm focusing on things like the distributive property, which students have learned and now they're applying here. And I'm taking the partial product. So I'm finding 3 times 20, and then I'm adding 3 times 4. So the way that you do this is, first of all, we show the kids that first they drop the 0, and they just bring that down. Next, they would take the 3 times the 2, and that gives them 6. So 3 times 20 is 60. Very concrete. Next, I'm going to take the 3 times the 4, and that's going to give me 12. And I'm going to add this up. Again, this is highlighting the distributive property, which kids have learned already in 3rd grade. And what I'm going to do is take 60 plus 12, and that's going to give me my same answer, 72. Again, kids can be very early on with multiplication and can already multiply 2 digits times 1 digit using this partial product model. So it's very powerful and helping build their understanding. So again, these are the strategies that we're using for showing multiplying 2 digits times 1 digit. The bar model, the base 10 model, the area model, and partial product. Once again, students are expected to understand all 4 and to apply them in homework, in assessments, and in work with teacher table in class. Again, we're building concept understanding in math and helping them to understand later on why the algorithm works as it does, and we're hoping to eliminate confusion with that rather than just kind of mindlessly following the steps and not understanding why they are there as they are. So thanks for watching. If you have any questions, please let us know. Hopefully this video is helpful to show the strategies we're using in math.